Hi everyone. I'll be talking about the basic introduction of the InfluxDB and some of its features, as well as how to install the InfluxDB and get started with creating the database in InfluxDB. So to begin with, InfluxDB is an open source database, meaning the original source code is made available and is redistributed and modified according to the user's requirements. It's a time series database. A time series database is the one that is optimized for time-stamped data. It's a computer system that is designed to store and retrieve data records that are part of time series, which is a set of data points that are associated with the timestamps. The timestamps provide a critical context for each of the data points and how they're related to each other. Also, time series data, InfluxDB was developed by the company called Influx Data, and it was initially released on 24th September 2013, whereas the most stable version was released on 13th April 2020 recently. InfluxDB is written in Go programming language. Go is a statically typed compiled programming language designed at Google. It's syntactically very similar to C programming language, but it has memory safety, garbage collection, structural typing, and so on, in addition to C's features. InfluxDB is completely written in Go, and it compiles into a single binary with no external dependencies. It is also optimized for fast, high availability storage and retrieval of time series data in fields. Talking about the features of the InfluxDB, it's a very expressive SQL-like query language. Just like we can see here at the bottom, the select query is very similar to SQL. And it has custom high-performance data store written specifically for time series data. It also uses the TSM engine, which is a time-structured merge tree that allows for the high ingestion speed and data compression. InfluxDB has the simple and high-performing HTTP APIs for the data ingestion and queries. It also has the built-in support for the other data protocols such as collected, graphite, etc. It stores billions of data points. It also has tag data for fast and efficient queries. Tag is simply a keyword that is assigned to a piece of information, such as internet bookmark, digital emails, etc. This kind of metadata helps to describe an item and allows it to be found again by browsing and searching. This makes queries fast and efficient. It also has retention policies that efficiently auto-expires the stale data, and the continuous queries that are automatically aggregated to make the frequent queries more efficient. Talking about the installation, the picture that I have here on the screen, this is basically to add the repository to the yum command. This is for the CentOS users. They can just install the latest stable version of InfluxDB using the yum package manager. So this command that I have here is used to add the repository to the yum package. And once we do this, we can use the yum command to install and start the InfluxDB. We can basically type sudo yum install InfluxDB and sudo service InfluxDB start to install and start the InfluxDB service. I have a link here that has all the information about what might be required to install InfluxDB. It just informs it has information about the basic requirements that we might need before installing the InfluxDB, and it also has the installation process for other for Ubuntu or Debian, Red Hat, Red Hat, and it also has information for CentOS, SLES, and OpenSUSE, and others. The link also has information on how to check the authenticity of the downloaded binary. So once we install the InfluxDB, we can start it by just entering the influx command, which will start the CLI and automatically connect it to the local InfluxDB instance. So now we're ready to create the database in the InfluxDB. We can just type create database and the name of our database, which is very similar to the SQL command that we studied. And now that the database is created, we can use the show database statement to display all the existing databases, which is very similar to SQL again. And we can also use the use database command after creating the database so that we can use the database, which is also similar to SQL. And finally, now that we created the database, InfluxDB is ready to accept the queries and writes. I have a link here that introduces the Influx query language for working with the data in InfluxDB databases.
All right, so now we're going to move on to the limitations of InfluxDB. Right here we have the top main 4 limitations. The first being that there is no join capability in InfluxDB, unlike many other databases. This is because there's no real set schema that is required to be defined and shared between all types of data in the database. Because of this, the schema is more flexible, it's more dynamic, it can be changed with when it's needed to be changed. This makes the join function not really possible, and thus it's not available within Influx database. The next limitation is that there are update and delete limitations. This is mainly done to increase the read and writing times and performances of the database. And in InfluxDB, the data is hardly ever updated because the time series data is dependent on the time that it was recorded, and thus updating those points of data don't really occur. Same thing with the delete. The only time the delete is used is to get rid of the old data sets that are no longer useful. And again, like I said before, this is mainly done to increase the performances of the read and the create functions in the database. The next limitation is the duplicate data conflicts. In InfluxDB, the database is created that in the way that if the same data is input twice, the system just recognizes it as the user trying to input the same data, and so it never creates a new instance of the data. It just doesn't really do anything. It just says that the user is trying to do the same thing it's already done. And then in very few instances, it does overwrite the data, and then so it will give it a new time, which is not always what we want. Then the last limitation is that it has kind of performance requirements. So for the database to perform at a higher or at a better rate, It's recommended that the user input the data in ascending time order. This is how the database is built, and if it's not really inputted in ascending order, the performance will significantly decrease and the database will become slower. Now we will move on to the comparison between SQL and Influx database. InfluxDB is built and optimized for time series data. This is data that is uh, based off, or the time is the primary key, you could say. It has a more flexible schema that can be changed over time, like I said before. It has a higher scalability and availability compared to SQL databases. And like I said before, it is faster to read and write in InfluxDB compared to SQLs. Although InfluxDB is less popular, more unstable, um, it does share a similar uh, query language to the SQL databases. SQL databases are not typically optimized for time series data. They're usually optimized for relational data. Um, their schema cannot be changed once it's created, so it's a set schema. It's static. It can't be changed once it's set for the database. That's what it is. SQL databases are more popular. They are more stable and consistent. And like I said before, they have similar query languages to the InfluxDB. And then on the bottom here, the graphic, we have companies that use InfluxDB compared to the companies that use MySQL. Trivago and CareerGain are some popular companies that use InfluxDB, but as you can see, the more popular companies like Airbnb, Netflix, Uber, and Dropbox do use MySQL. And then here we have a graph that compares the two types of databases. We have MySQL and InfluxDB. This is the write speed of the two databases. So you can see here, InfluxDB is typically around 3 times faster than MySQL for the write speeds. Like I said, this is just a characteristic of InfluxDB. But like I said before, a consequence of this for InfluxDB is that its delete and update functions are strictly restricted, and MySQL, they're not as restricted, so you can update the data better and you can delete the data better. Alrighty, and then here we have the two types of databases you would typically see in an SQL database and an InfluxDB database. Here on the right side, you have like the typical SQL databases that we've seen before. Here is this would be like a table that would be called like food chips, with having the attributes of park ID, planet, time, and the number of food chips recorded at that time. Just typical SQL database, but that database would look like the graphic on the left in InfluxDB. So each planet kind of has its own set of database or data called the series, based off its park ID. So as you see in the first series, has the name food chips, park ID of 1, the planet equals Earth. And then it has the time and the number of food chips, so the two characteristic pieces of data that make each point within the series unique. So for the first one, you see the time recorded there, and then you have the number of food chips, and then the time again, the number of food chips. Each of those is like some equivalent to like one of the rows, as you can see on the right, in the SQL database, and then you would move on to the next series, which would be Park ID 2 and Planet Saturn, and then Park ID 3 and Planet Jupiter, and so on. And then here we have our comparison to the other NoSQL databases. InfluxDB is one of the few time series based DBMS and is one of the most popular DBMSs compared to others such as Timescale, KDB Plus, and Prometheus. Um, like other top NoSQL, it is open source. However, unlike other NoSQLs, it is written in Go, while most other top NoSQLs are written in either C++ or Java or one of those more popular programming languages. And like other NoSQLs, has the sharding partitioning method, which is, like I said, similar to the other NoSQLs. And then, like I said before, InfluxDB is unique in the sense that it is a time series based DBMS. Most of the other popular NoSQLs are more document based storages, key values, or search engines. Some of them are also relational DBMSs. Thank you.
Alrighty, everyone. Today I'm going to be talking about the Influx database management systems uses and their integration with industry leaders to understand a little bit more about why Influx database is what it is and how it is used well. Um, as you've probably heard earlier, Influx database is used for time management or time series analysis and monitoring. It's very highly scalable and highly reliable, and it allows many companies to scale their databases larger than what they previously had, which is a great thing as a company is growing and getting bigger. And so many companies rely on Influx database management system to hold their data, whether it be through just monitoring and analytics to talking about how many people are staying in a certain place or whole 9 yards during a given time. But anyways, some of the uses that Influx database management system can have is the Internet of Things monitoring. The Internet of Things is basically just a group of physical objects that are connected to one another, such as like sensors, software, and other technology that basically can relay data through one another. And by using the Influx database management system, you can better understand the time analysis that it would take for one thing to contact the other or send a piece of data to one another during a given time, during a given event, whole 9 yards, or based on the type of data that's being sent. And like I touched on earlier, you also have time series analysis and analytics and monitoring is probably the main use of Influx database management system. And then there are a couple other databases that can do the same thing time series wise, but Influx does a very good job at it because it has real-time analytics and it has a deep insight analytics built into the system. And it basically allows people to get their information quicker and better understand and analyze their data more thoroughly than any other database out there. And so I included a image talking about the different runtime complexities of database management systems, and the higher the value, the better. And time series database management systems tend to run a lot more or a lot higher. I'm sorry, let me rephrase that. The higher the number, the worse. But with Influx takes that number and drops it because of how reliable and how quick it is. And so moving on to the industry integrations, there are a lot of industry leaders that are using Influx database management system to rely on monitoring and analyzing their data. And so there's a wide variety of different jobs or types of companies that are integrating the Influx database management system into their databases. And so, as for example, you've got, like I listed here, you have like finance with Charles Schwab, business services with Cisco, many technical companies such as JustWorks, Splunk, VMware, and Adobe. VMware and Adobe being two larger companies that many people have heard of. And then you have Cloudbeds for hospitality, basically being able to understand how many people are using their service at a given time, or how many people are staying in a certain place during a given time, a whole 9 yards. And then you have Comcast, which uses, Comcast is a networking company with TV channels and TV shows and whole 9 yards. They can monitor like watch time and the amount of people who've watched at a given time during certain events, whole 9 yards. And like I said, there are many other industry leaders that use Influx database management system to integrate their data with analyzing and monitoring and analytics. So now I wanted to talk a little bit about 3 companies in specific that have integrated their data with Influx database management systems. So the first one I wanted to talk about is actually Adobe, which many people have heard of Adobe. Adobe has a wide variety of uses. I mean, you got PDF viewers, Photoshop, Illustrator, Premiere Pro, whole 9 yards. And so whenever Adobe reached out to the Influx DB company, they basically were looking for a project to be able to like scale high-end monitoring for their microservice called Adobe EchoSign. And basically they needed something to integrate their Adobe EchoSign with the Microsoft SharePoint outline. And so the software engineering team at Adobe chose in the Influx database as the database for the SharePoint microservices because it requires a highly scalable and reliable database, which is something that the Influx database management system can provide to help the team achieve their requirements that they needed in order to integrate the EchoSign with the SharePoint outline. And so on top of that, you also have Comcast, which I mentioned earlier. They have like NBC, whole 9 yards. So Comcast was needing a database management system to monitor and telemetrize their data. And so with Influx database, they are able to measure their metrics, and it works very well for their cloud-based Foundry and their Kubernetes infrastructure. But with this approach, it's not just a single monolithic solution, but instead it's a collective of different tools that are performing for their purpose of enabling Comcast to take a certain component out that they may need to and then fill it in with a new one if they needed to, or a new one if they wanted to for the next greatest tool. If they were needing to update their software, hardware, whole 9 yards, they're able to do it because of how reliable and how scalable and how quick the Influx database management system is, being able to interchange things easier and quicker than if you were using a different type of database management system. Alrighty, and then the last thing I wanted to talk about is PayPal. PayPal also partnered with Influx database management system to do end-to-end solution for PayPal as a vendor. I didn't list them here, but basically PayPal, of course, is through finance. And so Influx Database Enterprise provides an end-to-end solution from one vendor as PayPal was seeking to another. And then using the Influx data platform, PayPal built a monitoring solution that works at scale and in the process. And then the monitoring, ingest, collectors, and alerting platforms team at PayPal has developed their best practices formulated for scaling the Influx database enterprise system in their environment. And that is something that PayPal now uses a lot more as they continue to grow. I mean, PayPal is a large company, but they're still growing now as more things are moving online a whole 9 yards. And that's what a lot of companies have been doing, is since they've been moving online, they've been needing to upgrade their database management systems and integrate newer technologies to help with the inflow of data being stored online now. And so a lot of people are starting to look to Influx database as a way of time series solutions. So other than that, I think that's about it.
So the first thing you want to do is to start your InfluxDB server. And if you're on Windows, you want to execute the influxd.exe file. Or if you're on Mac or Linux, you could just run the influxd command in your terminal. So after your server starts running, you should get a screen that looks like this. And then after that, to actually run the Influx command line interface, again, we could just execute this influx.exe file. Or if you're on Mac or Linux, you could just use the influx command in your terminal. Okay, so now to create a database, InfluxQL has a lot of similarities with MySQL. And in fact, creating a database is quite similar to what we've seen in class. So we could just do something like create database mydb. And you may have noticed that there's no semicolon and we get no error when we hit enter. So it seems like what we did got executed. And in fact, if we do something like show databases, you'll see that in fact mydb did get created. There it is. So just like with MySQL, once we've created it, we want to use it. So again, we could just use and then the name of our database, mydb. And there it is. We're now using the database mydb. So now that we have a database, InfluxDB is ready to accept queries and writes for all sorts of data. But this is where things get a little bit different from what we've seen with MySQL. It's important to note that InfluxDB is used for time series data, and this corresponds to a bunch of points of you can think of it as a bunch of points on a graph that each have a certain value over a period of time. So perhaps you want to see how temperature fluctuates over time, or maybe monitor and get data on how much CPU usage your computer uses. If you've ever looked at a task manager on your computer, this could be an example of what a time series would be. This could give you some intuition as to what we're doing, right? See, because every second or so we have a corresponding value, and it shows you what all the values were over a period of time. So this is a time series, but how can we model data that looks like this? How can we model data over time? So it turns out that in InfluxDB, we can define a point, quote unquote, by the following criterion. A point consists of 1, a timestamp, 2, a measurement name. You can almost think of this as the name of the table or what we're trying to capture over that time period. 3, at least one key value field. So this is the thing that we're actually collecting the data of. And 4, any metadata tags, any other relevant information that we should know about the stuff we're gathering. Okay, so to insert a single time series data point, we use the insert command. And here's an example that I pulled straight from the InfluxDB documentation. It's insert CPU, host equals server A, region equals US_west, value equals 0.64. So we hit enter, and it looks like everything went through. So if we select all from CPU, there it is. We got our value of 0.64 and its corresponding time value. So in this case, if we break down our insert command here, we have that CPU is the measurement name. In this case, our key value, which we conveniently called value, is 0.64. Host and region were metadata tags. This isn't stuff that we actually want to, visualize on one of those fancy graphs, but it's important information for the data that we're gathering. And of course, we have this timestamp, which we didn't actually specify in the insert command, but if you don't actually specify one, InfluxDB will generate one based on the time of your computer. You can almost think of a timestamp as the primary key in MySQL, and the other things as columns, and the measurement name as the name of the table. So let's populate this a bit more. Say I want to insert 0.73 and then 0.52. And then I can select everything from the CPU table, and we have more data points. But typically we don't want to manually input data like this, because what if our time intervals are nanoseconds apart, and then we have data for multiple hours or even days? it would be really tedious to have to input each one of those one by one by one. And this is a good time to explain something else about InfluxDB, and that's that there's no update command in InfluxDB like in other SQLs. There is no update, but we can reinsert by specifying a timestamp. So, for example, let's say that this last thing that we entered was a typo, this 0.52. Let's say that we actually wanted to input a 0.62. Well, then we can update, quote unquote, by just reinserting that value. So we could do something like insert CPU and then all that other stuff. And we actually wanted 0.62. And then to actually update this, we need to specify that the timestamp that it gave us. So that would be 160.50.50.745.746.280.700. Okay, looks like it worked. And then let's check real quick. Use the select from, and yeah. See, now our 0.52 is now 0.62, but our time series value didn't change. So we actually did update the value there. And also something else about InfluxDB is that typically we don't want to delete an entry from a time series. So like, let's say we wanted to remove this middle column. We typically don't want to remove an entry like that, because the whole point of a time series is that you have evenly distanced discrete intervals of time that all have some corresponding value. So if you take out like data points from a time series, it kind of messes with the visualization aspect of it. But again, if necessary, there is a way of doing this, and it's quite similar. You just you use the delete keyword and then just specify the time number that the value had. So here, if we wanted to delete that middle entry, we would delete from CPU where time equals, and then we need to give this exact time series, this timestamp number. And then looks like it worked. Select from CPU, and it's gone. And then of course, if we want to delete the entire time series, which we can do drop series from CPU. And then you'll see that if we try to select, there's nothing there. So, or we can drop the database altogether by using the drop command. So do like drop database, what was it called, mydb, and then if we show databases, mydb's gone. So I've shown you guys a brief introduction into the CRUD of InfluxDB in the command line, but in newer versions of InfluxDB there's actually a graphical user interface that's quite easy to use. This part won't be on the homework, but it's kind of cool, and so I'll just show you guys. So we get a page that looks like this, and then it gives you an option to just load data. Like here we can add like a demo data that just sort of to show you guys what this is all about. I think I already preloaded it. So if we go to, where is it? Is it boards? Yeah, if we go to boards and we click on the demo data, you see that this is what we're working with. So it looks like this is data for some sort of like, we're like monitoring like a website or something. So we have like response time, status code, and if we look down here, we see that this is more or less what we're working with, that we saw when we were inserting and updating stuff in the command line. So we still have like a timestamp here, method and server. These would be like our metadata tags, the HTTP response code, or the response time. These are like the values that we're trying to keep track of and visualize. What's cool about this is that if we go over here to the Explore tab, we can actually visualize it we can actually visualize the data or query stuff about it within the actual GUI. So here, if we want to like show the response times that we have, I think those are all fluctuating quite a bit. We can just hit submit, and bam, we have a bunch of data that's really nicely laid out. And then from here, we could, of course, analyze this, make predictions, and stuff like that.